All right. Let's look at a different example. We just did this problem on population growth here. Let's talk about continuously compounded interest. The continuously compounded interest formula, if you look it up, some people call it the PERT formula, okay? But the PERT formula is just a rebranding of the exponential growth formula, okay? So really this is this, right? They both have T. Here it's called R for interest rate. Here it's generalized to just be K as a growth rate. And then instead of P, now P stands for principal. And when you're talking about money or you're talking about investment or anything like that, principal is a different term for the initial amount, which is what this is, okay? So, and then this is the amount after some period of growth. So the PERT formula is just a rebranding or a more specific version of this, but all of these variables mean the exact same thing. Okay, so I'm only stating that because if somebody wanted to look up a continuously compound interest formula, it would probably say this, but that is the same as this, which is what we saw in the previous problem. Okay, so let's go here. Remember, this is the initial amount, this is the growth rate, this is a unit of time, how long it grows for, and then this is the amount after that period of growth. So this question says, at what continuously compounded rate, okay? At what rate? So that's the question, right? They're asking you for the rate. So this is going to be our variable in this problem. K is what we're going to be solving for, okay? Must you invest $10,000 if your goal is to have $14,000 in 9 years? So $10,000 is our initial amount. All right, E is E, not a variable. K is the rate that we're trying to determine. This is going to go for 9 years. And the account balance you want is $14,000. Okay? So, how do we solve this equation? How do we get K? How do we solve for K? Again, K is in the exponential level. I can't solve for K until I get it in line with everything else here. So I need to knock this exponent down to the first level. We do that by logging both sides, okay? But I cannot do that until I've isolated that power. The 10,000 is not a part of that power, right? The exponent is only the exponent for what it's touching, and this is touching E, okay? So we need to get rid of this 10,000. So the first thing we're going to do to isolate that power, we're going to divide by 10,000 on both sides, okay? So we get E, and I'm going to write this as 9K, 9 times K over here, and then over here we've got 1.4. 14,000 divided by 10,000 is 1.4. Now I've isolated the power, okay? To get this exponent to come down, to have K be in line with everything on the first level of that problem, I have to take the natural log of both sides. So I'm going to take the natural log, and I can do any logarithm. I could do common log, I could do log base 4 million, it doesn't matter what the base is, okay? But for the simplicity's sake, we make it natural log, and we'll talk about why in a second, okay? So we end up with the natural log of 1.4 equals, now that I've used this operation, the 9K comes down in front. I'm going to put parentheses around that. So we have this. We did take the natural log of E, so that's still there. And then the 9K just came down in front of it. Okay? And this is what I mentioned before. We can choose any logarithm, but we choose natural log because the natural log is log base E. So the natural log of E is log base E of E. And what is the value of a logarithm where the base and the argument match? It's always 1. So this natural log of E is equal to 1. Okay? Now I didn't do this in the other video, but I will just here to re-emphasize this point, that the natural log of E is not a variable statement. It has a value. Its value is 1. So I can replace it with the number 1. Now, when I multiply 9K times 1, I get 9K. Okay, so we have the natural log of 1.4, and I haven't calculated this yet. I could, but a logarithm represents a number. So rather than getting the gross decimal for this, I'm just going to leave that for now. Okay, and then I'm gonna divide by 9 to get that value of k. So we get k is approximately whatever the natural log of 1.4 divided by 9 is. .0373, we'll say, 374. So we get 0.0374. Now that is, our growth rates are always written as decimals, but they represent percentages, okay? And I think we mentioned that here. We mentioned how to do the calculation, we have to have the decimal form of that, but this represents a percentage of growth, okay? Same thing applies when we're solving here. We got this decimal, but as a percentage, that's 3.74%, okay? So we have to use the decimal in the formula as long as we understand that it represents a percentage rate, an interest rate, all right?